2024 planners. Welcome to today's geography lesson. My name is Cynthia Zondi and my co-presenter is Rina van Heerde. This lesson is brought to you by the Gauteng Department of Education in collaboration with Cyborg Discovery Center. Okay, boys and girls, we are today going to look at lesson 6 of 2024, and the topic that we are going to be looking at is drainage systems in South Africa and a bit of Mapwork, which is what you were taught in this week. Okay, so our lesson objective is going to be based on revision on the work that you were taught in this past week as it is Friday today. Right, we are going to look at the concepts where we have to explain or look into the definition of the concept, identification and application of these concepts that you are also going to be revising today. So we're going to look at the definition and identification of drainage basin, catchment area, river system, tributary, the confluence, watershed, interflow, source. We're also going to look at the concept of river mouth, the concept of surface runoff, infiltration, groundwater, and water table. So these are the concepts that we are going to look at. We also are going to look at a revision on identification of the underlying rock strata development and characteristics of the drainage patterns. So we're going to be identifying the drainage patterns. We look at the rock strata that is underlying, and we look at how it develops as well as its characteristics. And then these drainage patterns that we are going to look at is the dendritic drainage pattern, the trellis, the rectangular drainage pattern, radial, centripetal, deranged, and parallel drainage patterns. We also are going to look at the different types of rivers, and with that we're going to look at how we define each of those. We look at how do we identify them, and also we apply the knowledge and understanding of what brings in the difference between these types of rivers, which is the permanent river, river, periodic river, episodic, as well as the exotic river. So these are the 4 types of the rivers that we are going to look at. And then we are also going to look at the definition and impact of factors influencing drainage density. So we're going to look at what is drainage density, and we're also looking at the factors that influence this drainage density. So with drainage density, we're going to look at the comparison of the high drainage density and that one of low drainage density. Right. Also, boys and girls, in our lesson that we are looking at the revision of concepts such as precipitation, evaporation, looking at the soil moisture, the vegetation, the influence of slope and slope, or you can say gradient, and then we're also going to look at how these influence the drainage density, which is porosity and permeability. So all these are linked to drainage density, which then explains why you would find some of the drainage basins having high density and the others having a low drainage density. Okay, then furthermore, we are going to look at Mapwork, as I have indicated to you, as per the annual teaching plan, what you were taught this week, which is the cross section linked to the concept of intervisibility, And we also are going to look at the calculation of vertical exaggeration. Right. So here are your study tips for this week. We want you to really grasp these concepts as early as you can, since we are looking into a new topic now, which is on geomorphology. So you have to study the content that you were taught over the weekend, like the content that you were taught for this week. And then also make sure that you find the past exam question papers, and you also exercise some of those activities that you can find from the previous question papers. Then you should also listen to video clips. Remember, it would be very much helpful to get to listen to a different voice other than the one that you are used to in class. That can also help you to have a better understanding. We also advise you that you should identify those subtopics you don't understand. So the subtopics that when you project into what you were taught this week and you realize that I don't understand some of the concepts here, then you have to consult with your teacher there. And then you need to draw up a mind map. So this is one of the study tips of making sure that you collect much of understanding from whatever that you are taught. Then draw up a mind map for yourself. In some of the resources that you have, they do have mind maps, but if you want to test whether you have an understanding of certain things that you were taught, you need to do it all by yourself so that you can see which of the concepts maybe you are missing, and you can be able to put more emphasis on those. Okay. The concepts that we are going to look at in this lesson, we're going to look at what drainage basin is, and river system, catchment area. We're also looking at the concept of what a tributary is, and we should also be able to identify all these on the diagrams or pictures. We also are going to look at the concept of confluence, what confluence means, what a watershed is, and then we're also going to look at what an interflow is, and also concepts such as what is a source, and also being able to identify it on the illustration. So all these concepts, you need to know how to define them. You must be able to identify it, and you also use your application of knowledge on each one of them. Remember, if you are able to have an understanding of all this, you will be able to answer those key geographical questions that we always emphasize. What is it? Where do we find it? How does it look like? And what is the impact of those? So some of the concepts that we are further going to look at is the concept of a river mouth, what is a surface runoff, and what is infiltration. We're also going to look at the concept of groundwater, which also brings in the other concept of water table, which shouldn't be confused. So all these concepts, they also need or require you to be able to answer those geographical questions that I have indicated: definition, application, and also illustration. Right. Okay, we have a diagram sheet here that is showing you the concepts of what a source is. As you can see there, we are identifying the source where the river starts, and then we are identifying the concept of mouth where the river ends. But what am I trying to illustrate here? With the whole circle that you can see here, what is key, we are looking at a drainage basin. So all this area, the whole area drained by the river system here would be what a drainage basin is. So it's an area drained by a river and its tributary. So when you look at this river, you can see this is the main river. This is the main river that we are looking at. But what we can identify here, there are tributaries that are joining in. So when we look at the whole area where now this river drains its water by the river itself, including its tributary, we refer to it as a drainage basin. Okay. Then we've got another illustration here, which also we are going to look at the concept of a catchment area. Okay, so what is a catchment area? A catchment area is the area receiving, rain and supplying water to the river system. So it means when we look at this whole area, the whole illustration that we can find here, or the surface area that we can just bring down here, we're looking at what a catchment area is. So it is the area that receives rain, as you can see from the illustration here. This rain, it falls on this particular area. There is rain that is shown here. So all the areas that receive the rainfall and supply the water to the river system. So it means when we look at all the water that will then be moving down to join this main stream, it forms part of what the catchment area. So the area where rain falls, which is the high-lying area, obviously. So this whole area where it collects the rain, and then it then supplies this particular water to a river system. We refer to it as a catchment area. So you should be able to define it in that form. Then we are looking at the concept of a river system. So what we have here, we have a river, which is the main river that we can identify here. And then from this particular river, we can identify the tributary that is joining this particular river. So here's the river that we are talking about. And then this particular river is joined by a tributary. So a river plus a tributary equals what we call a river system. So what forms a river system? It's a river and its tributary. I may not only be pointing to one tributary, there would be more tributaries that are joining this particular river. So a main river that we can identify here, together with its tributary, they form what we call a river system. All right, so a river system is a river with its tributaries. A river with its tributaries is a river system. So we're combining this plus that, which makes the river system. Okay, then let's look at what we can then say. What is a tributary? A tributary is a river or a stream flowing into a larger river. So it is a river or a smaller stream that is flowing into. So key things that you need to identify here, it flows into a what? Into a larger river. So on its own, this is a river, but it's just a smaller stream. Then we then refer to it as a tributary because it is not in its own existence, but it then supplies water into the main river. So this particular tributary is a small stream that would flow and join the main stream. All right. Then the other concept that I want to see you understanding it's the concept of a confluence. So now we are looking at a confluence. It is a point where two rivers meet. So where two rivers meet, we refer to it as a confluence. So what do we see here? You can see there's a tributary, and then there's the source, and it's the tributary. We can see that this river starts there, and then it flows into this particular main river. So the point where the smaller stream, which is a tributary, meets up with the main river, or this particular river, we refer to it as a confluence. Okay. Right. Then now we are looking at a watershed. So as you can see, boys and girls, that what we have here, we've got these particular small streams, all this. Where are these getting the water? From a high-lying area. So a watershed is this high-lying area that you can identify right at the top there. So a high-lying area separating different drainage basins, meaning when we were to look on the other side of this hill, we would find also another river system like this one. So this drainage basin, it is on the other side of what? Of a watershed. So a watershed, it is a high-lying area that separates different drainage basins. So there would be a drainage basin on the side, and there would be another drainage basin that you can identify on that other side of the hill or the mountain range. Yeah. So that is a watershed. And then within this diagram, what else can we identify? We can look at what an interflow or interflow is, which is the high dry patches of areas that we can find between the tributaries. So these ones now we find them between. So I said to you, there is a tributary here, and then there is another tributary there. So the surface area that is dry that we can identify here, this surface area that we can identify between the two tributaries, we refer to it as an interflow. So this would be an interflow, this would be an interflow. And here also in this smallest area here, we can see that there's two streams, then there would be an interflow, which is that high dry area that is separating the tributaries there. So that is what a watershed is, as well as a interflow. So you shouldn't confuse the two concepts, because with the interflow it separates the drainage basin, but the interflow we find it in between the tributaries. All right. Then we are looking at where now we say the river starts, which is the beginning of all streams. So all these areas that you can identify here, these are your source, because all of these streams are starting right there. So the beginning of all streams in the higher lying area. Obviously, a river would flow from a high lying area to a low lying area. So where do we find the source? The source, we find it on the high lying area. Right. And then we are now looking at the concept of the river mouth. So where now the river ends in the sea. So that is the part where, as you can see, all these tributaries, they were flowing from the source right into the mainstream, and then the flow ended up where? Onto the sea. So this, we refer to it as the river mouth. Right, other concepts that you also have to have an understanding and must be able to identify them. It's what a surface runoff is, which in this diagram, it is indicated as the overland flow. So the river, the water rather, it is flowing, or the water runs over the surface of the earth during and after precipitation. And where does it end up? It ends up in the river. So it ends up in the river. So when it rains, when the surface area has reached the saturation, where now we cannot have more water that is infiltrating the ground, the water will start to flow away on the surface. So as it flows on the surface, then it is channeled into a river, and it ends up where? Into a river. So this water that would be flowing on the surface after precipitation, it's referred to as a surface runoff. Okay. The other concept that you should also have a clear understanding of is infiltration. So all these now, we are looking at concepts that are referring to when it's raining. So when there is rainfall, as you can see from the diagram itself, it shows that this particular area is receiving rainfall. So we have identified the surface runoff. So part of what you also need to identify is that there would be infiltration. Some of the water would then infiltrate the ground. So infiltration is the process by which water on the ground surface enters the soil. So the surface where water can be able to pass through, it will enter the ground surface. As you can see from the use of color here, that we use the brown color to illustrate that now we are referring to the underground surface. So the process where water passes through, we say it then infiltrates the ground. And then we've got other concepts like underground water flow. So there's this concept of groundwater flow, which is water that is stored in porous soil and rock masses. So this is your groundwater, water that is stored in porous. Porous are rocks that have, porous soil, we're referring to soil that has got pores, and therefore water can be able to pass through. So when water passes through, then it gets stored there, or even if it's a porous rock, water would be stored within those rocks, and it would form part of a groundwater. Water table. This is another illustration. This is the top level. So from the word itself, table, when you talk about table, it has the top level. So the top level of the groundwater, beneath the water table, the soil is saturated with water. So when water passes through via the processes of infiltration, and it forms part of what? It forms part of the groundwater. What then happens is this groundwater would have the top level. So that top level of the groundwater is what we refer to as water table. So beneath the water table, the soil is saturated. So the water cannot pass through further. So it would then have reached the saturation. And when it reaches the saturation, it will then leave the water at the level of water table. Okay. Right. I hope you did understand all those concepts that I was explaining. And then we are now going to look at the types of rivers. Right. We've got 4 types of rivers, which is, the first one is your permanent rivers. When we describe what permanent rivers are, we say these are rivers that flow throughout the year. So throughout the year, it's permanent. So there's a permanent flow of water throughout the year. Then we've got the second type, which is the periodic river. The periodic river, even the name itself, it suggests the understanding, periodic. So this would be a river that only, keyword there, only flows in the rainy season. So we can now draw the distinction here to say it only, so there's a specification of time here, where hence we look at the concept of period. So it only flows when? In the rainy season. So thus we term it a periodic river. And then the third one is the episodic river. Episode. So there's element of time there also that you can identify here. So it only flows after a heavy rainstorm. So when we have an episode of heavy rainfall, then this particular river would then be able to have its water flowing because of that a heavy episode of rainfall. So meaning the water level would have only risen up because of that heavy rainstorm. Right? The fourth one is your exotic river. This is a permanent river. So that's one thing that you need to note there. It is a permanent river that originates in a rainy or the wet area. So unlike this one, which we said it flows throughout the year, this one, it is a type of a permanent river, yes, but its origin is dependent on what? On the area, whether it is from a wet area, but then it later flows through a desert. So it means that the source of this particular river would be what? A rainy area. So these type of rivers, their source is from rainy area, but in which direction do they flow? They flow towards a desert area. So they flow from high rainfall areas into areas that are having limited or no rainfall. So we refer to them as exotic river. So we shouldn't confuse it with this one. So here the difference is brought in by the fact that its origin is dependent on whether it is from a high rainfall area. So in South Africa, for an example, when you look at our high rainfall areas, it would be rivers that would flow from the east of the country, because those are the areas that have got high percentage of rainfall. And then such a river would then flow onto the west of the country, where now is more of desert areas then. Okay, let's see the illustration of these types of rivers. So from the description, we can see that this is a picture that is showing you a water that is flowing throughout the year. And then what is it that we can identify as the characteristics? So this type of rivers, okay, this is where your focus is. This is the river that we are looking at. So it's a cross-section of the river. So we're looking at the level of what? Of the water table. So we're looking at the comparison of the water table during a rainy season and during a dry season. So when you look at this diagram, you can see, boys and girls, that this water table, this solid line that you can see here, it is when it is during a rainy season. So obviously this water, the water table here, it's directly in contact with the surface of the river. So the river is flowing throughout there. And then also even during winter, where now we're looking at the broken lines that are showing you a different season, which is the dry season here. The water table has intercepted the riverbed, and it's still the dry season. So this particular river can still be able to flow during a dry season. So there's continuous supply of water onto the riverbed. So the water table intercepts the riverbed throughout the year. So that is the explanation of what brings in the difference between the rainy season and the dry season. So there is, although the level would still be low, but even in the dry season, this water table would still be intercepting the riverbed. Okay, so here how do we identify that? When we are now onto our Mapwork section, this would be the map clip that can show you this type of a river. As you can see here from this illustration, that this particular river, it is a river that would be, if we are using a map, it would be those maps that areas of high rainfall. So what can you identify here? There's this thick solid blue line that is showing that this particular river is flowing throughout. There is high volumes of water throughout in that area. Then we're looking at the illustration of a periodic river. So looking at the cross section here, we are now looking at the comparison of the water table during a rainy season, which is, you can see that, okay, the water table is higher. So there is water that would be flowing at this time. Then we then look at the comparison of where now it is during a dry season. So in the dry season, what happens now? The water table has dropped to this level that you can see here. So then from looking at the diagram, you can see that the riverbed, which is this part of the riverbed, is not in contact with the water table. So look at where the water table is and look at where the riverbed is. So obviously it means this particular river will not flow during a dry season. So the water table intercepts the riverbed only when during the rainy season. So that is the difference that you can draw from what we saw in the previous illustration. All right, then when we go to our map clip, where now we need to show the difference of what we have identified in the previous map clip. So with this one, can you see now the width of this particular river that we are looking at here? It's now smaller. So there is little amount of water that is flowing in this particular river. So the river only flows during the rainy season. So you should also be able to draw the difference when you look at the width of the blue line that indicates the river there. Then we've got an episodic river, which is the river that would flow after an episode of heavy rainfall. Right, we still have our cross section that is showing us the river. There's our river valley that you can identify there. And then look at the level of the water table now. In the rainy season, the water table is below the riverbed. And then also during the dry season, the water table is still far from intercepting the riverbed. And then we then indicated that this one, it would be after an episode of a heavy rainstorm. Okay, water table never intercepts the riverbed. So it is only after a heavy rainfall that we can see this particular river flowing. Right, on your topographical map, how do you identify this type of river? What you see here on the illustration, these broken blue lines. So the lines here are not solid, but they are just broken. It would be a non-perennial type of a river that would be illustrated there. Then the river flow for a short period of time after a heavy rainfall. So a short period of time. So hence you would find that there are some sections of the river, as you saw in the picture there, there's some rocks that are just not covered with water there. Right, an episodic river, it flows all year round, and then the river, that's the characteristic that we have explained. A river is supplied with water where they begin to originate or rise, but little water is added as they flow towards the sea. Okay. Then the other thing that we need to note about an episodic river, these rivers reflect the characteristics of their source region. So they also are dependent on their source region, not the region through which they are flowing. So they are also would be determined by their source region. And then, for example, we are looking at the Orange River. Rather, those characteristics, let me just go back and correct this. So here we're not looking at episodic, rather we're looking at an exotic river. This would be an exotic river. Right. So the example of a river that we say it would be an example of an exotic river is an Orange River in South Africa, and north of Africa we would be looking at the Nile River. Okay. So let's look at this explanation of a typical exotic river that we can see in illustration here. So what we have here, we've got Orange River. The Orange River, where is its origin? As you can see, for example, this is the map of South Africa, and this section that we are looking at is the east of the country. So this river would be flowing in that direction. As you follow through onto the arrows here, it would flow in that direction, which is your Orange River, towards the east of the country. And then its mouth would be onto the east of the country, which we can identify there. And then what are the characteristics of what forms this particular river? It is that it flows from the area of high rainfall. So this would be an area of high rainfall. And which direction is it flowing? It flows onto an area of low rainfall. So this river is the exotic river. And then what do we find alongside this Orange River? It's the Vaal River, which is now a tributary. So can you see now? So from this tributary, which is the Vaal River, it adds more water at the point of confluence. So this would be at the point of confluence of both the Vaal and the Orange River. And then we would have more supply of water in that direction towards the east of the country, or on the Namib region there. Right, therefore, the Orange River flows from east to west. So as you saw there. Right, this is just a picture that is showing you the Orange River. We can see that this is a river that is flowing permanent. From the diagram, you can see that it's a permanent river. It has got high water levels. And if you were to illustrate it on the topographic map, it would be those periodic, rather the perennial river. Okay, so we've got the illustration of the Orange River, which originates on the Maluti Mountains. So these mountains, from the concepts that we have discussed earlier, then we would say the whole area that is draining from which mountain? From the Maluti Mountains, it forms part of the Orange River drainage basin. Okay, so all these high-lying areas that are draining water in that direction would be the catchment areas. And then the other thing that I can also emphasize is that these high-lying areas there would be a watershed, which is the high-lying area that separates two drainage basins. So this is you should be able to find how to illustrate those concepts, even just by looking at the diagram, and also identifying your interflux. For an example, you must be able to identify that this would be an interflux, because we can see that there is some valley that we can identify there, and then between the interflux there would be a smaller stream that is flowing in that direction. Okay, so deep in Drakensberg in Lesotho, known as Sengu River, originates or rises and flows into South Africa major river, which is the Orange River. And then it is of many kilometers away, and then from where the river leaves Lesotho and enters South Africa. The river brings with it old mysteries and legends to the untold treasures of long forgotten secrets. So this is just giving us the background of the Orange River that is flowing from Lesotho down the Drakensberg Mountains onto the onto South Africa. Then. Okay, this is just another illustration of the west now. We are now looking at the west of the country, which is the Orange River mouth of Alexander Bay on the west coast. Okay, the Orange River southern, the Orange River in the southern Africa's longest waterway rises in the Drakensberg Mountains of Lesotho, only 195 kilometers from the Indian Ocean. So you can see the element of the east as it is brought in to be the origin there. Yet it chooses to turn west, flowing 2,300 kilometers to the South Atlantic. So now you can see also where we can identify that it is flowing to the west and then towards the South Atlantic, carrying fresh water into the area with some parched land and servicing as a linear oasis through the arid would mean the dry Karoo and southern Namib Desert. So this is where now we can identify the Orange River that has now flown in its direction towards the west of the country there. Right, you have a worksheet which is based on what we have discussed. It says use figure 1.2, which shows different fluvial processes and characteristics of drainage basin to assist you to give one term to each of the descriptions below. So before you can attempt the questions, you must look into the diagram. Okay. So your first question, area where a river gets its water from. The second question, area drained by a river and its tributaries. The point where a tributary meets the main stream. High-lying area that separates two drainage basins. Where a small river flows into a bigger river. Okay, so these are your questions. I am going to give you 2 minutes to jot down your answers quickly, and then we will look at what would be the correct answers. Rather, let me go back. These are your questions. You've got 2 minutes to respond to this worksheet.
Good afternoon, grade 12 learners. From my side, welcome back. Ms. Dondi gave you worksheet 1 to do, where you have to read through the statement and you need to write a term for that description. So how this one differs from previous ones, here we give you the definition, we want the concept. Okay, so I hope you wrote down some answers. Let's check the answers and you compare your answer with our answer. The first question, area where a river gets its water from is a catchment area. Remember we said it's the area where it rains and that rains that flow on the earth's surface. An area drained by a river and its tributaries is a drainage basin. There's the keyword, area drained by a river and its tributaries. The point where a tributary meets the main stream is a confluence. A high-lying area that separates two drainage basins is a watershed, and where a small river flows into a big river is a tributary. And there you can even see in that diagram, there's lots of answers that can guide you to these answers. Okay, boys and girls, we go over to drainage patterns. When you do drainage patterns, you need to know what are the different drainage patterns. You need to be able to identify. That means if they give you a diagram, you must fit that diagram with the pattern. You must know what is the underlying rock structure, how does it develop, and what are the characteristics of that specific drainage pattern. So the first one is the dendritic pattern, underlying rock structure, uniform rocks of similar hardness like granite, gneiss, volcanic rock, and sedimentary rock. But it's not been folded, so it's just flat rock. It got uniform rocks of similar hardness. That means everywhere it will erode the same, equal resistance to erosion. Developed, we have many sub-tributaries. These are your sub-tributaries, which merge into tributaries of the main river. These are my sub-tributaries, and remember these are all the tributaries that flows into the main river. But all of these tributaries has got sub-tributaries. Now, what is the characteristic of the dendritic pattern? It looks like the branches of a tree. If you look at this, you can see it almost looks like a tree. The tributaries here join at an acute angle. So this is the characteristic. It will be recommendable that you study this slide as is. The trellis pattern. This is how the trellis pattern looks. How you're going to identify it, I will show you now. Underlying rock structure, gentle sloping, alternating layers of hard and soft rock. So in this part, I will have my soft rock. Yeah, I will have hard rock, soft rock, hard rock. So it's alternating the one after the other one. So I have a layer that's hard, I have a layer that is soft. It's along a strike valley, smaller tributaries feed into the steep slope of mountainside. So here I have at the bottom. So it's going from the side, it's going to look like this. So I have a river here and I have a river there. The water flows, these tributaries flows down, so it's flowing down. So here in the middle, I have my interflow. Now this water flows down the slope into the valley. That valley at the bottom. But very important is these streams are flowing parallel to each other. They're flowing parallel, and this is main stream joined by short tributaries at right angles. Okay, so how do I identify? You just look for rivers that flow parallel to each other. with then its tributaries. Now, how do I know it? It forms normally by areas of hard alternating, hard and soft rock. Rectangular pattern. Now, if you look at this pattern, you have to be able to identify it. There's one thing that I see. I see tributaries are joining a main stream with a bend of 90 degrees. If you look there, 90 degrees, 90 degrees, 90 degrees, 90 degrees. So it means it is rectangular. How does the underlying rock structure look? Each area with a hard rock that's well jointed. That means it's the area where the rocks are jointed, has got cracks. The joints are usually less resistant to erosion than the bulk rock. So erosion tends to open these joints, and a stream, due to erosion, those joints will open and water will flow in there. How do I know it? Characteristic, I look at 90 degrees bend. A radial pattern. Radial means spiral, it's going out round. So I have, for example, a butte or a mesa in the middle. Now water is flowing in different directions down from this mesa or butte. It flows away from the high central point. The tributaries form a summit follow that slopes downwards, and it drains down in all directions. It looks like the spokes of a wheel when you look at it from above. So you first look for the high line, the copy, so the mesa and the butte in the middle, and then the rivers that are draining down, and it looks like the spokes of a wheel. Centripetal is now just the opposite of radial. It's the area where there's a dam or a lake here in the middle. It's the dam or the lake down there. So I have water flowing in all directions down to the dam or the lake. I have fluvial networks which converge towards the central depression. That depression is the dam or the lake, and the stream flows towards a central depression. It flows down. A deranged pattern, it's a Demakar pattern. There's no specific pattern. The blue you will see are dams or lakes. The area has been much geologically disruptive. Rivers have not had time to adapt to the underlying rock structure, and they follow an irregular flow of glacial deposits. It develops when high hills, valleys, and depressions dictate the flow path. It results then in a patchy, unpredictable network. It's just a Demakar spill, an irregular, broken drainage system where there's no pattern. But what we can see somewhere in this pattern, we have small dams or lakes. A parallel pattern. Here you can see, look here by the way, the river flows like this. And then all of them flow to one point there, and it becomes one river. So this river flows in a southwesterly direction. It occurs in regions with pronounced slopes with uniform rock resistance, meaning the rock erodes at a similar rate through the landscape. Rivers and streams flow roughly parallel lines over this sloping surface. Streams are swift and straight, you can see it, swift and straight, with few tributaries. I'm talking about in this example 6 tributaries, and all of them and everything flows in one direction, and that is in a southwesterly direction. Boys and girls, I'm going to give you time now Yeah, I have worksheet 2. Refer to figure 2.2 on different range patterns and match each of the descriptions below with one of the drainage patterns A to E. You may choose the same drainage pattern more than once. So I'm giving you the definition or the description, and you now have to match this description with A, B, C, D, or E. Let's give you 2 minutes for this worksheet. Welcome back, boys and girls. Let's correlate or let's look at your answers for each quiz. Okay. Stream pattern associated with rocks that have equal resistance to erosion will be A. A is dendritic. 2. The main streams that are parallel to each other is C. Here you can see, you see the hard rocks and the soft rocks, the hard rocks and the soft rocks. So it's got, but these streams are flowing parallel to each other, so it belongs to C. Main streams that have 90 degrees bends along its course. 90, 90, 90. It belongs to D. Streams with an irregular pattern, we said it's Democard, it's that one. There's no specific pattern, it's number B. Rivers that flows away from a central point. There's my central point, so it's flowing away. So the answer is going to be E. Remember they said more than once. You can use some of them more than once. A drainage pattern that forms on rocks that have varying resistance to erosion due to folding. There you can see they are folded. It is also C. Tributaries that join the main stream at an acute angle. Sorry, an acute angle is like that or like that. And the answer can be D, or you can also have A for this one. Okay, I hope you have a very, very nice 7 out of 7 there. Let's look at this video on drainage patterns.
Drainage, Part 2. Drainage patterns. The streams within a drainage basin form certain patterns depending on the slope of land, underlying rock structures, as well as the climatic conditions of the area. These are dendritic, trellis, rectangular, and radial patterns. The dendritic pattern develops where the river channel follows the slope of the terrain. The stream with its tributaries resembles the branches of a tree, thus the name dendritic. A river joined by its tributaries at approximately right angles develops a trellis pattern. A trellis drainage pattern develops where hard and soft rocks exist parallel to each other. A rectangular drainage pattern develops on a strongly jointed rocky terrain. The radial pattern develops when streams flow in different directions from a central peak or dome-like structure. A combination of several patterns may be found in the same drainage basin.
Thank you for that. I hope you've enjoyed that. We're going over now to drainage density. We get two types of density, high or low. You do get average though, but the big difference between the two is that the one is high and the one is low. Now, what is drainage density? It relates to the efficiency by which water is carried over the landscape. You can see there's a separation between the two. At high density, I can see more streams. With low density, I see fewer streams. That's the basic difference between the two. Now, what you need to know is the factors which influence drainage density. What is going to determine if there are more tributaries or less tributaries? Precipitation is one. If it's not raining that much, I have less rainfall and it's easily absorbed by the soil and results in high infiltration. That means soft continuous rain infiltrates into the soil rather than flowing flow on the surface. That means those water, if it infiltrates, I can't see it anymore. However, when rainfall is high, there's not enough time for this water to infiltrate into the soil, so it starts running off as surface runoff. So, in an area with high rainfall, I will have high density. In an area with less rainfall, we will have less density. Here is what I said just now. Evaporation. If there's less evaporation, that means it's not that hot in that area. I have more surface runoff, therefore high density. Where it's an area with more evaporation, it evaporates when it's very warm and very hot. I have less surface runoff, therefore low density. The next factor is soil moisture. Dry soil can quickly absorb water. If my soil is lying there, it was hot for a few days, and it starts raining, that soil is hungry for water, so it absorbs the water. Therefore, infiltration is high, and in comparison with wet soil, if there is already water in that soil, that water can't, the soil is saturated. So that water is not going to infiltrate, it's going to stay on the surface. Therefore, a wet soil promotes runoff, therefore high density. Vegetation. What does vegetation do? If there's lots of vegetation and it rains, the roots of the vegetation absorbs the water. Therefore, I have high infiltration and high density. In vegetated areas, we are having low drainage water, exactly what I said now, because of high infiltration, while unvegetated area with less vegetation, I have a high drainage density because there's no roots of plants to absorb the water. Slope is another factor. A steep slope generally does not allow water to infiltrate. It's running off. The slope is too steep for the water to infiltrate, so it starts running off, so I will have a high drainage density. Steep slope, high drainage density. Gentle slope, low drainage density. Because of a gentle slope, the water will infiltrate into the soil. Then there's a word porosity. Porous rocks or soils allows water to easily infiltrate to underground reservoirs, such as sand soil. Sand soils have large particles or granules that create space in between, so water can easily infiltrate without any difficulty. Therefore, sandy soil or porosity rocks have a low drainage density. However, if I have clay soil that are compacted and cemented together, the water will struggle to infiltrate. So I will have runoff. Therefore, I will have high drainage density. Permeability. Permeable rocks such as limestone absorbs water easily, which leads to infiltration, while rocks such as basalt and granite are hard and impermeable. That means areas with permeable rocks have a low drainage density because the water is absorbed, while areas with impermeable rocks have a high drainage density because that water is running off. Okay, boys and girls, here we have a sketch, worksheet 3. What is a drainage pattern? Name drainage pattern A and B. Give evidence from the diagram to support your choices. Compare the underlying rock structure of drainage pattern A and B in the sketch. Draw a simple labeled plan view sketch of a drainage pattern that will develop in folded landscape. Let me just quickly go back. I think, do we have 2 minutes for this activity? It's a bit more writing, so I wanted to start immediately, and after 2 minutes we will check the answer. Thank you, boys and girls. I hope you have answers for these questions. Let's check your answers. I want you to mark your answers to see where you are right or wrong so that you can learn from your mistake. What is a drainage pattern? Remember the definition. It's the way in which streams are arranged within a drainage pattern, or you can say the surface pattern formed by a river and its tributaries. So it's any one of the two. Again, a concept that you must know, and look there, if you know it, you have your 2 marks. Name drainage pattern A and B, and what is nice, they even gave you the simpler one. Now, if you see this anticline and syncline, it must already give you the answer for the number B. So A will be dendritic and B is rectangular. How do I know it? Look at that right 90-degree angle. Next. 253. Give evidence from the diagram to support your choices in question 2.5.2. A, dendritic. It resembles the branches of a tree and the tributaries join the mainstream at acute or small angles. Then for drainage pattern B, where is that one? Rivers have right angle bends. I showed you, there you can see it goes in there. There's my 90 degrees. The tributaries intersect the main river at 90 degrees as the river flows along joints and cracks on the overlaying rocks. You know, one of the impacts of folding and faulting. Folding is that there can be faulting. Grade 10 work. Then we come to the question. Compare the underlying rock structure of drainage pattern A and B in the sketch. A develops where the underlying rocks are horizontally, or a very popular one is it's uniformly resistant to rocks. Drainage pattern B develops on well-jointed and cracked rock. Draw a simple labeled plan view sketch of a drainage pattern that will develop in folded landscape, and that will be your trailer. Boys and girls, we're going over to Mapwork now, and I want you to follow this video on how to draw a cross section.
Hi and welcome to this lesson. Today I'll explain to you how to draw a cross section of a certain area on a contour map. So let's zoom in on the map and see how it's done. So here you can see the contour lines. Bear in mind that if you see a number 20 over there, then it means every single place on this contour line over here is 20 meters above sea level. Doesn't matter where you go. You might also find that there is a note on your map telling you exactly what the contour interval is. Now, what I'm going to do first is to put a piece of paper exactly on this line over here. We know that this line is 20 meters above sea level. So here's where we're going to write 20. And let's do the same on the other side. Okay, then we move to the next line. We know the interval is 20, so we write 40. These ones are quite close, so I'm going to draw this line down. And then the next one we know is 60. Then we go to 80, 100, 120, and then as we can see, this line here is 140. This is once again going to be 140. Now here is where you must make a note to remind yourself that this area here between these two lines, or where these lines cross the horizontal line, is higher than 140 unless there's something strange going on there. But so make a plus here. Very important to place your piece of paper properly and make sure it doesn't move. Otherwise, your cross-section won't be accurate. Right, let's go to step number 2. Okay, step number 2 now, once again, it's very important not to let your paper slip. And here we have 20, so you just make a little marker there, same on the other side. I just want to make 100% sure that I'm working accurately. Now we are going to move them up. Make sure that you line up your piece of paper as accurate as possible. And here is where we are going to make the next marker. There we can see this is 40. 40 is over there. And then we move the paper up once more, up to 60. So now we are simply going to connect these markers. Here's 20. This is a very steep slope, as you can see. Now, here is where you have to guess more or less what the top of the hill looks like. So you can do it however you want. And that is your cross section. Thanks for watching, and feel free to subscribe, and don't forget to watch my other Mapwork videos. See you next time.
Very easy. Something that always looks to us difficult is actually very easy. Now, together with a cross-section question is an intervisibility question. What is intervisibility? Intervisibility refers to whether one point on a map is visible. That means you can see from another point. So I have 2 points, A and I have B. Now the question is, if you are at A, will you be able to see B? Now, there's, for example, I've got this, on this side I've got the Pole Rock. And you can see here, there's the dam. And here I have a school. Now the question is the Pole Rock visible from the dam? Now here's the school. There's the S for the school. I want to know if I will be able to see the dam if I'm at the school. Now if you take your cross section, and you will see there's the school. I go up and up and up. Then I reach this point where the Pole Rock is, and that's how Pole Rock looks. Then Pole Rock is there, which is 543 meters above sea level. Then we go a bit higher to 0.654. Spot height 654 is there, where it seems at that point it's 754 meters above sea level. Then we drop because the dam is at 600. So, if normally the school is 180 meters above sea level and the dam is 60, under normal conditions you will be able to see the school. But in this case it's not going to happen because Pole Rock and spot height 654 is creating an obstacle. I can't look over it. How do we, now we come to the next calculation on vertical exaggeration. That refers to the amount by which the vertical scale of a cross-section is made bigger compared to the map scale. So, very important to remember when we calculate vertical exaggeration is that both your scales must be a ratio scale. So what are your two scales? Your two scales is a vertical scale and a horizontal scale. But they always give you the vertical scale in a word form. So what must I do with my vertical scale? I must convert my word scale to a ratio scale. That is step 1 before you calculate vertical exaggeration. But only if the vertical scale is not a ratio scale already. So I have 1 centimeter, I have 20 meters. So what must I do? I must go take it to a ratio scale. So I want both sides to be centimeters. So what must I do? I take that 20 meters, I times it by 100 so that I can get 2,000. So my vertical scale now is 1 to 2,000. Now what is the formula for vertical exaggeration? It's vertical scale divided by horizontal scale. VH stands for vertical scale, HS stands for horizontal scale. Now what you always must remember, a ratio, if I write it 1 to 2,000, 1 to 2,000 also means 1 over 2,000. So what did I do here is I took that vertical scale, which was 1 to 2,000, and I've made it a ratio scale. I've put the one on top of the other one. Now that dividing line must still be there. So I have 1 over 2,000 divided by 1 over 50,000. So now if you go back to basic mathematics, we are going to do the following. I'm now going to say that 1 over 2,000, remember the opposite of divide is multiply. Then I multiply 50,000 divided by 1. So let's do that. 1, 2, 3, 1, 2, 3. 1 times 50 equals 50. 2 times 1 is 2. So I have here basically 50 divided by 2, which is 25 times. When you do vertical exaggeration, your answer must always have the word times in. Very easy. Very easy. And let's check this video quickly on vertical exaggeration.
Today I'll be explaining vertical exaggeration and how to calculate vertical exaggeration. But before we can do that, we need to understand what a cross-section is and how to draw a cross-section. Now, I'm not going to draw a cross-section today, but you can click the link down in the description section below and it will take you straight to my video on how to draw a cross-section. But I'll explain the concept just quickly. Let's say you have a loaf of bread and you look at this loaf of bread right from the top. Okay, my artistic skills are not really that great, but let's say this is what your loaf of bread looks like when you look at it from the top. Now it's possible to cut this piece of bread in half. And then what you would see is what it looks like from the side, and this is what we call a cross section. So it might look something like this. Normally it goes wider at the top, and then this is more or less what it looks like. So the same thing happens when we draw a cross section of a piece of land. What we basically do is we cut that piece of land in half and then we look at it from the side. Now that we understand what a cross section is, we need to ask ourselves, what is vertical exaggeration and why do we use it? Now, what we need to bear in mind is when we take a cross section of a certain area and we make it smaller so it can fit onto a piece of paper, we obviously make it smaller many times. And then what we very often see is that it's so difficult to identify things like mountains, valleys, slopes, and so on. And that is why we exaggerate the vertical scale so these things will be more easy to identify. I'm going to show you a quick example. So if you're an athlete and you're preparing for a marathon, And once you've entered, then what they normally do is they send you a cross section of the route, so you'll be able to see where you'll be running up and where you'll be going down. And if we don't use vertical exaggeration, in other words, if we don't exaggerate the vertical scale, then it will be quite difficult for you to see where you'll be going up and where you'll be going down, and it will look something like this. Maybe it's not the perfect example. If you take a quick look at this, the line is more, well, it's not really straight, but it's hard to see where you'll be going up, where you'll be going down. And so what they do is they exaggerate the vertical scale and send you a cross section of that. So what you see here at the bottom is an example of the same area, the same cross section, but the vertical scale has been exaggerated. So when we calculate vertical exaggeration, it's important to memorize the formula, and the formula is the following. Vertical exaggeration equals vertical scale over horizontal scale. Now your teacher will give you two different scales, and the first one is the vertical scale, and let's say the vertical scale is 4 millimeters equals 20 meters, and your horizontal scale is 1 to 50,000. Now what we want to do next is convert this scale into something similar to this scale, because we want to compare apples with apples. So firstly, we need to convert meters to millimeters, and so let's start. But I'm gonna write this slightly differently, because we are doing a division calculation here. And so what we'll do is the following. We will say 4 millimeters equals 20,000 millimeters divided by 1 to 50,000. So we are working in millimeters here. And now what we need to do next is we need to simplify what we see here. So we are going to divide by 4 here and divide by 4 on this side. And what we'll have is the following: 1, and 20,000 divided by 4 is 5,000. So now we have 1 to 5,000 divided by 1 to 50,000. So we don't actually need the brackets. But what now we are going to write it as a fraction again. And so we have 1 divided by 5,000 divided by 1 over 50,000. Now what we do in maths is, when we do a division sum like this, is we swap these two numbers and then we do a multiplication sum. So now we have 50,000 divided by 5,000, and what we'll get is 10. So the vertical exaggeration is 10 times. So what does this mean? It simply means that the vertical scale has been exaggerated 10 times so that we'll be able to see those mountains and hills and slopes and valleys and so on. So this is how simple it is. Thanks very much for watching once again. Feel free to subscribe and see you next time. Goodbye.
Thank you, boys and girls. You see, it's very important that you know why we have each one of these calculations. Now, for the worksheet 4, I want you to determine the vertical exaggeration of the following question. There you can see it's your vertical scale, and then your horizontal scale is also always the bottom one. For time's sake, I'm going to do this one with you. So there it is, my vertical scale. I have to convert it, so it became 1 to 2,000 over 1 to 50,000. So I say 1 over 2,000, 1 over 50. Remember, I divide, so when I divide it becomes a multiplication. So at the end I have again 50 divided by 2 gives you 25 times. Thank you, boys and girls. Prepare this weekend all the work that was taught the past week. We want to wish you good luck and see you next